parentheses. All right. And there we go. Perfect. All right, so 3 little warm-up questions for you today, guys. And once we get through these, we will we'll go over them and then start our new material. And this is a good segue into today's lesson. Last week we had talked about solving some equations. In the past, we've dealt with decimals and fractions and percents. This will be a good little review for us. All right, give you guys about 30 more seconds. I made the mistake yesterday of doing some yard work without socks on. My shoe rubbed a daggum blister on my foot. It's been killing me this morning. But I found a Band-Aid over there, so it's all good. All right, Charlie, you might not be finished with all 3 of them, but did you get an answer for number 1? Griffith. Or Charlie. There we go.
I put 11 minus x in parentheses.
11 minus x in parentheses.
And then a 2 on the left side. And then a minus 6 on the right side.
Minus 6. All right. So when we translate something like what, thank you, Charlie. When we translate something like this, we want to read the whole thing first. We don't want to just start writing things down, because if I just started writing things down, I might write the number 6 first, but it says 6 less than something else, right? And so the notion of that is, like, if I said, hey, what is 6 inches less than your height? You're not going to say 6 minus whatever your height is. You're going to say your height minus 6. It's inverted, okay? And so when we look at 6 less than something, we're going to go ahead and say that something minus 6. And then you ask, okay, well, what is that something? And I think he had said a 2 on the left. I misheard what he said. But when we look at twice the difference, twice something means that we're going to multiply something by 2. And then the difference being that subtraction, 11 and a number. Okay, so those are the 3 parts right here that we want to make sure we have translated in the proper order. 6 less than something means we're taking 6 away from it. What are we taking something away from? We're taking 6 away from twice the difference of 11 minus x. Questions on number 1? Okay. Now today we're going to be doing a lot of work with kind of introducing word problems and how you should generally approach those. That's a prerequisite skill right there, what you guys just did, being able to translate English into math, okay? And you and I are going to talk about some other translations that you'll be required to do, but things like knowing that difference means subtraction, okay? Knowing that less than means subtraction, more than means addition, right? Sum means addition. Twice, thrice, things like that, 5 times, those are multiplications, right? Quotient means division, all that good stuff, okay? So we'll talk about squaring and the word of meaning multiply, the word is meaning equals, all that good stuff. Grove, what about 4.5%? All right, so 0.045 as a decimal. Very good. He moved it to the left 2 spots. Okay, and Joey, what does that mean I need to do to convert 0.6 to a percent? All right, so if we got 0.6, that's going to be moving it to the right 2 spots. So that would be 60%, right? Reed, what's 1 as far as a percent? So if 0.6 is 60%, what would be 1? Now think about it like this. If I've got 0.6 and I move it to the right 2 spots to get 60%, then 1, right? I'm going to move it to the right 2 spots and get what? 100%. Good. So that's a good little reminder for us, isn't it? That 1 equals 100%. Anything less than 1 is less than 100%. Anything more than 1 is more than 100%. So like if I had 1.5, you guys would say that's what? 150%. Okay, so again, remember, being able to convert back and forth between decimals and percents is an important skill. And then this last one, we had a little equation that I asked you guys to work on solving, right? And so let's see here. If Luke, what was your first step on this example here on number 3, Mr. Sublette?
Use the distributive property with 11. So I did 11 times 3, and then 11 times 8.
Mm-hmm. So 33x plus 88. All right, very nice. We didn't have any distribution to do over there. Will Edwards, what about this other distribution? Okay, so Luke took care of the first one. What about the second one? Very good. Did y'all hold on a second? Let me pause. Make sure you heard what he said. He didn't say distribute 2. He said distribute -2. All right, very good. I was hoping you'd say that. Will, go ahead, buddy. Negative 26x plus 2. And that plus 2 is the number 1 mistake spot right there. Okay, that's the number 1 hurdle to get over. Most students that make a mistake on this problem forget to distribute the negative with the 2. Okay, so when you're subtracting a group, it's the same old trope that I roll out. Oh, dadgummit, Reed, I'm tired of your row, get out. And I'm not just going to take Reed. I'm going to take Reed and Nate. I'm going to take both terms. Okay, subtracting a group means you subtract both of them. Reed right now is like, that might not be a bad thing, actually. But you're just joking, right, Reed? Yeah, that a boy. Your hesitation is unnerving, son. All right, Jake, combine some like terms for me, please. We're on that right-hand side.
You do 33x minus 26x.
And you get, what is that?
7x.
7x. All right, and we can all put 88 and 2 together and get 90. All right, 7x plus 42. Now, I've run out of room, but George, you might kind of read the writing on the wall here. What would my next step be?
Subtract 7x.
All right, so we're going to subtract 7x from both sides. And you got 42 equals 90. Now, how do you feel about that? Does 42 equal 90? No, it does not. Therefore, we would say, Jake, I see a hand up, actually. What's up, buddy?
I don't really understand how you got that on the right side. Like, how did you get minus 26x?
All right. So good question. Let's take this chunk right here and pull it down and kind of focus in on it, okay? So we're saying minus 2 times the group. I felt like I was about to sneeze, so I took my mic off. But I think my sneeze has disappeared. All right, so we're saying minus 2 times the group, okay? Now, minus 2 is the same thing as plus negative 2 times the group, okay? And that's that distribution that we're going to do where we say negative 2 times 13x and negative 2 times 1, all right? And another way of looking at that is just saying a negative times a positive yields a negative. So we got negative 26x. And then a negative times a negative yields, I think I misspoke a moment ago. A negative times a positive yields a negative, and a negative times a negative yields a positive. So that's why this winds up being plus 2. So we got our negative 26x from this part. And then we got our plus 2 from this part because there's a negative times a negative. Does that help a little bit, Jake?
Yes, sir.
Okay, awesome. And so, class, what do we say when we've got something kind of kooky like positive 42 is supposed to equal positive 90? What do we think about that?
No solution.
Yeah, that's a contradiction. It contradicts what we know to be true about numbers, and therefore we would say no solution on this one. So this equation, there is no answer that I could possibly plug in to make that statement true, no matter what. Okay, so it has no solution. All right, make sense, Nate? You good? You got straight? All right. So that being said, our warm-up complete. Look at these 5 steps for solving word problems. Okay. Now you don't have to write all of these down. I'm going to highlight the basics that I want you to get down. Okay. So the first step, when it talks about read the problem, make sure all the words and ideas are understood, identify what we're looking for. You know, the idea is to figure out what they're asking. To say, what is this problem asking me to solve? It might be you're asked to figure out how many cups of flour are needed for this new recipe. It might be that you're trying to figure out how far apart Denver and Chicago are. It might be that you're trying to figure out, how long it took Billy to rake the leaves in the backyard. Whatever it is, whatever the word problem is, the first step is figure out what they're asking. Okay? Figure out what they're asking. All right. Second thing we're going to do is we're going to assign a variable. Okay. The second thing is we're going to assign a variable. Now, I would recommend writing that when you're working the problem, like say, let X stand for the unknown number of muffins. Okay. Or let Y equal the amount of time spent working on the leaves, or whatever it is that's unknown. Like actually declare the variable. Okay. So step 2, declare the variable, where you tell somebody that's reading the problem, you say, hey, Coach Morgan, this is what that translates to, or this is what that variable stands for. Okay. Step 3 is the hardest one. Okay. Step 3 is write an equation. Write an equation. Now I put a little star by that one in my notes usually because that's the hardest one. Man, if you can get over that one, then it's all, it's smooth sailing from there. Jake, your hand is still up. Do you have another question?
No, sir. Sorry, I didn't take it down.
That's all good. Okay, so we got step 3. That's the hardest one, fellas, where we're going to have to, sometimes it requires prior knowledge. Okay, you know what I'm saying? Andrew, what do I mean by prior knowledge?
Knowledge you had before learning.
Yeah, so like you guys give me an example of like something that y'all roll into algebra already knowing. Any formulas come to mind? Jack? Okay, well, distributive property, yeah, yeah. Do y'all already know the area of a circle, for example? Anybody know that one? Nobody knows what the area of a circle is? Jack? No, bro. Your first word out of your mouth ought to be pi. Joey? Pi r squared. Holy moly, y'all got to get some prior knowledge up in here. Let me try a simpler one. Do y'all know the area of a rectangle? There we go. Everybody's like length times width. Yeah, I know that one. Okay, so like there will be like some prior knowledge. Like Jack gave a good example a minute ago about like the distributive property and whatnot. So like the things that we have put in our toolbox so far this year or last year, that's what you're going to use to cobble this equation together. Okay, along with translating some words from English into math. All right, step 4 is the easiest one, I think. Step 4 is the easiest one. Solve the equation. Okay, at this point, y'all have become pretty proficient at solving equations. Problems like we saw, example 5. Okay, so solve the equation. And then the last one is to answer the question. Answer the question. Oops, I highlighted the wrong part. There we go. Answer the question. Oops. There we go. Because if I ask, how long does it take Jack to paint the fence? And you tell me how long it takes Alex to paint the fence, you have not answered my question. So like if you solve for, like let's say that A is the amount of time it takes Alex to paint the fence, and J is the amount of time it takes Jack to paint the fence, and I ask how long it takes Jack, and you tell me A equals 5. A equals 5 hours. You have not answered the question. You might have solved the equation, but then you didn't go back and do step 5, which is to answer the question. You say, oh, well, if A equals 5, then J equals 4, or whatever. Okay? So make sure you guys have these steps down. And they ought to be where we use them enough to where you're comfortably attacking them. Now, look, I've been in your shoes before, okay? Twice, actually. I took algebra as an 8th grader, and I took it again as a 9th grader, okay? And the first go through, I just thought, this is easy. I do math. I'm good at math. I'm little Mr. Morgan, the mathlete, whatever. And, I would just jump into a problem feet first, okay, and just say, all right, let me figure this out. And I'd start playing around with it, and I'd figure a lot of them out. But I never really had a method, a background to fall upon. And so when the problems got tougher, I was not able to just say, oh, let me figure this out. I needed a recipe to follow. Okay, I needed steps to go through. And so these steps are what I'm giving you guys now. All right, let's look at a couple of examples. All right, we'll start with the easy ones. Okay, now this example 1 is short enough, so you can write it down verbatim. Okay, the sum of 7 times a number and 8 is 36. Find the number. Okay, so first of all, the word sum. All right, Joe Edwards, what does sum mean?
Addition.
All right, very good. So I know I'm adding 2 things. Okay, there's going to be something over here on the left. There's going to be something over here on the right. I'm adding the 2 things together. Let's see what they are. They're going to be separated by the and, by the way. The sum of this and that. Well, this goes on one side of the plus. That goes on the other side of the plus. All right, so let's see what that first thing is. 7 times a number. Lewis Thomas, translate 7 times a number.
7n or any other variable.
7n is fine by me. Okay, so that's my first term. And then my second term would be 8. The sum of 7 times a number and 8. So those are my 2 terms. Okay. What does the word is mean? Good. Can we make sure we got that written down? Is means equals. If I say my height is 6 feet, then my height equals 6 feet. If I say my age is 36, then my age equals 36. Okay. So we would write equals, and then of course the number 36 is what it equals. So we have done step 1, step 2, and step 3. We figured out what they wanted. They wanted to know what this magic number is, this unknown number. Step 2, we didn't actually declare the variable. We didn't say, let n be our unknown number. It's kind of implied in the problem. And then step 3, we just wrote the equations, doing a straight up translation. That required zero prior knowledge. Okay, just a straight up definitions, swapping out like is for equals and times for multiply, and you get the idea. Now, step 4 is to solve it. Okay, now I want you guys to go ahead and run away and solve that one. Paul Camillo, question. While we wait for Paul to ask his question, you guys go ahead and solve that.
Could you go back up to the other steps because I wasn't able to write them down?
And remember, you don't have to write all of those down, just the highlighted parts.
All right. But could you go back up?
Yeah, it's back up. Do you not see it on your screen?
No.
Really?
No, I can't see it.
What's the thing that you see at the top of your screen?
I only see step 4 and 5.
Mm.
There we
Anybody
go.
else? Anybody else seeing it that way at home? No. Paul, did you say it lagged out?
Yeah.
Okay. Is it fixed?
Yes, it is.
Oh, sweet. Okay, perfect. All right, Georgie boy, you got a solution? 4. Does anybody concur with that solution? You don't know what concur means? Does anybody agree with that solution?
Yeah.
Okay. There's a, oh man, I may have told y'all this already. Did I tell you guys about the word concur and the movie Catch Me If You Can, Leonardo DiCaprio? No. There's a movie, it's a Steven Spielberg movie with Tom Hanks and Leonardo DiCaprio and Jennifer Garner. And it's about a guy named Frank Abagnale. It's a real life story where he goes on just a spree of check fraud, like across the nation. He impersonates somebody, cashes a bunch of checks in their name, and then skips town with all the money and the stuff. And so anyway, he is impersonating a doctor, like down in Louisiana, and at this clinic, there's a nighttime injury, and so he's the doctor on staff there, and they wheel this guy, and he's got like a compound leg fracture, bone sticking out of his leg, just a nasty mess. And so, of course, he's not a doctor. He's not used to seeing this, and so he's got his 2 little interns with him. And so they wheel this guy up on a gurney, and they're like, "Doctor, what do you think?" And he's like, and he's trying not to get sick. And so he tells his little interns, he's like, "Doctor, what do you think?" And so the first intern looks at it, and he's like, I mean, it's a compound leg fracture, doctor. And so he's like, "All right, doctor." And he points to the second guy. "Do you concur?" And the second guy's like, I mean, it's obviously a leg fracture, but the second guy thinks it's like a trick question. He's like, and Leonardo's like, "Do you concur?" And he's like, "Yes." He's like, "Great, take him to surgery, go." And he's about to get sick, so he leaves. And the second doctor's just shaking his head like, "Why didn't I concur? Why didn't I concur?" So you guys now know that if you agree with George, George says the answer is what? 4. If you concur with George, that means you got an answer of 4 as well, right? Mossy, how do we get 4? Give me my 2 steps that I have to go to get that 4. Hello, Mossy. Unmute yourself, bub. And Paul, you can put your hand down.
Okay.
Massimo Valentino, answer me, son. Bah. All right, Tiago, I'll give you a shot. Mossy's not there.
First, you subtract 8 from 36. And then you have 28. And 28 divided by 7 is 4.
Perfect. N equals 4. All right. Seems as though I've got somebody said something in the chat. I wonder if this is Mossy. We'll see. All right, so I got N equals 4. You guys try the second one. Example 2 on your own. My mic does not work. Okay, Mossy, I got you, brother. Someone else started sharing. What the dump? Oh.
Why do I just see a hole?
I see how it is. One of you goobers accidentally did that. All right, let me see if I can figure out how to fix that. Somebody requested or took control. All right, I'll share my screen again. There's a setting I need to fix to where that doesn't accidentally happen to you guys. So we're working example 2 here. Tiago, you can mute yourself, buddy. Oh, rats. Hold on. Now, this one, interestingly enough, when you look at that first sentence, it says the sum of 2 numbers, neither of which is known. So what do you think you'll have to use? Okay, so you said a variable, but if there's 2 unknowns, am I going to need a variable, as in singular, or dot, dot, dot? Somebody, come on, I'm laying it on pretty daggone thick. What? 2 variables. If there are 2 unknowns, I need to use 2 variables. Okay. Did you guys know that that was legal? Oh, you can use 2 variables. Alex, you already finished this one? All right, focus, brother. I'm going to actually declare my variables on this one. I'm going to say let A equal the first variable, first unknown number. I'm going to say let B equal the second unknown number. Okay. Paul, you have a hand up. What's up?
I can't see anything. The screen is black.
Paul. Is that happening to anybody else?
Oh wait, it just came back. I don't know what happened there.
Well, you know, I have found in this life that sometimes it just takes asking the question. Like I'll go down to the tech lady's office and I'll say, hey, I've had this issue. And then as soon as I pull it up, the issue is gone and it's fixed. It's magic. I don't know what it is. But no worries, buddy.
Okay.
All right. So the sum of these 2 numbers, I would express that as what? A plus B. And that sum is negative 15. And then it says one number. So we get to pick one. Which one do you guys want to pick, A or B? Of course, Jack says B. We're going to go with B. B, and then the word is, what does is mean again? Equals. So B equals 9 less than the other. Now, 9 less than the other, that's inverted, right? So the other would be A. So how do I write the right-hand side? A minus 9. Superb. Now, listen to what, because I'm almost out of time. B equals A minus 9. So we can use a notion known as substitution. We could say instead of B in that first equation, I could plug in what? What does B the same thing as? A minus 9. And looky, you guys now have an equation that you could solve. So instead of A plus B, we got A plus A minus 9. Now that's a little bit more advanced. I'll leave the rest of that for you guys to solve. You should end up with 2A equals negative 6, so maybe A equals negative 3, something like that, and you can find what the other number is. But that's an example of how you can translate and you can be stuck, and there might need to be a little bit of some prior knowledge. You know, Jack mentioned the distributive property earlier. The substitution principle is something else that you guys have all had a little bit of work with. You know, plug and chug. We talk about that. So this is a good example of that. Okay, and I'll leave you guys to solve that last equation there. You get what A equals. And remember what step 5 says. Step 5 says answer the question, and they said find the numbers plural. So if I find that A equals -3, I need to figure out what B equals. That should be -12, by the way. Excuse me if I'm not mistaken. Okay? But I'll leave you off right there. Our time is up. And remember, you guys that are here in person tomorrow, I want you guys to try and log in using your what? CBHS login. And then you guys at home also, let's try that if you didn't do that today. So like JMZ Tacos and CJ Cause 333, all that good stuff. You guys have a wonderful day. Live Jesus in our hearts. All right. Thank you, boys.